All right. Great. Well, good afternoon, everyone. Happy Friday, and welcome to the second webinar in our Computational and Data Science Curriculum Development Series. I'm Kate Cahill. I'm Associate Director of HPC at NJIT, and I lead the CDS Exchange project, where we're working on solutions to support faculty who want to teach computational and data science and share curriculum and develop new materials. And today we're going to hear from our data visualization expert on the project, Dr. Vitria Bird of Purdue University. Who's going to talk all about our data visualization resources and ideas for the future. And so all yours, Vitria.
Hey, good afternoon. Thank you so much, Kate, for that introduction, and welcome everyone. I'm excited to be here. I'm going to share my screen so that you can see the presentation. So, Kate, can you see my screen?
I can see the PowerPoint.
Okay, excellent. Okay, so today, this is the second webinar for the webinar series. I'm delighted to be here to share with you some resources and my thoughts and presentation on data visualization for computational and data science. Just a little bit about me. I am an associate professor here at Purdue. I am a computer scientist and biomedical engineer by training and a data visualization scientist by experience. So I'm not going to read all the rest of the things that are on the slide, but I want to go down to the bottom of the slide. So if I were in person, I would show you guys my superhero of science stance. But I can save that for another day. When we do, maybe we'll have an in-person workshop. So just wanted to kind of set the stage to let you know that I have been working in this area for some time, and just to kind of give you some background on that. So today I'm going to be introducing a framework, and I added resources because as I started to prepare this presentation, I started thinking about the diverse background of the audience. And so one of the challenges with data visualization is knowing who your audience is and then trying to prepare content for that. So you will find that this presentation is kind of a high-level overview, but also intended to be an introduction. So I added introducing a framework and resources for guiding the novice visualizer through the development of insightful and informative visual representations of data. So I want to just take a second to define what I call a novice visualizer. And so I am under the assumption that you are here because you're interested in data visualization, but not exactly an expert. Or maybe you're here, you have had some data visualization training, and you're just here to refresh what your knowledge is, or maybe to see if there's anything new that is being presented. And so when I say novice visualizer, I have presented or prepared this presentation with that in mind. So anyone who views this video at a later time, or if you're here now, you should be able to, and hopefully feel comfortable enough following along and asking questions if you have them. So as an overview, we're going to do a few things today. We're going to talk about data visualization. I'm going to define data visualization, or how I view data visualization, because if you talk to 10 different people, you probably get 10 different answers as to what data visualization is. So I think it's important to put that up front to define how I view data visualization. We're going to look at the data visualization process. We're going to talk about how do we go from data to insight. And then from there, I have some information about data visualization for computation. So what are some visualization tools for big data analytics and visualization tools for computation? From there, we'll look at data visualization for data science. I'll present some essential skills for data visualization, and keep in mind the information that I'm presenting here today are things that I feel are essential for you to know. Do not treat this as the absolute end all for all things data visualization, because I have to give you a disclaimer that this webinar is just touching or scratching the surface. There is so much more that could be and should be included, but given the time, I tried to come up with some content that can be and will be relevant to all of you. And then lastly, because we're looking at building curriculum, I will take a moment to talk about a data visualization tool that I am developing or working on to help teachers and learners in data visualization. And so I also have some other resources that I will provide for each one of these categories. These are not all of the resources, but I just wanted in the effort to be thorough in my presentation here. I've listed just a few of these things, few of the resources that you will have access to after this webinar. So let's get started. So data visualization is a process, and I think it's very important to state that. It's a process of transforming raw, complex data into visual representation that does not overwhelm. Most people think data visualization is just creating a picture. That's only a part of it. So I want you to be thinking about it's a process, which means it's not a one and done thing. You need to allow enough time for yourself to actually work through this process. And so I view data science as the study of data to extract meaningful insights. So where does data visualization fit into the realm of data science? We all know that data science is a combination of different disciplines. So you have computer science, machine learning, math and statistics, you have subject matter expertise, traditional software, and traditional research. All of those things combined, or data visualization, I think is the glue that holds these things together. It is that tool and or skill, because there has been some conversation around, is data visualization a tool or is it a skill? And to that question, I say yes, because it can be both of those things. And so I view data visualization as the glue that allows for interdisciplinary work. It allows for collaborations. It allows for so many different types of things. And so I've positioned data visualization in the center of this Venn diagram that you see here, which makes up data science. So there are four general types of visualizations. Exploratory, you have no hypothesis about the data, you just want to explore it. And I've worked on some projects where a person has said, hey, here's some data. I don't know what it means, you figure it out. And so in those instances, it's great if your passion is working with different types of data. It allows you to explore the data interactively as undirected searches. And so you go into the project or working with the data with no expectations of what you're going to find, but hoping to figure out, or hoping that data visualization process will help you to provide some insights as to what type of answers or questions can be answered with the data. Sometimes you will create visualizations just to confirm a specific hypothesis about the data. This type of visualization is goal-oriented. It's an examination of the hypotheses that you have. Sometimes we create visualizations for the pure aesthetics of it all. So it's a presentation. So you already know what your data looks like, you know the results, and you want to be able to visually represent it in such a way, as I said before, that it makes sense, that it informs, but does not overwhelm. And so selecting the appropriate presentation techniques is going to be crucial when you're in this stage, or if you're creating the visualizations for this purpose. And all of the visualizations that you create will be for presentation. It's just a matter of what medium are you using. And then lastly, the other type of visualization is interactive visualizations. And if you've ever been on a web page and you clicked on something, a graphic, and that initiated some type of motion, or maybe a drill down feature, that's what's called an interactive visualization. And in this case, you know what part of the data you want to be animated. And so this way, this gives you an opportunity to think about what are the different types of tools that you would need that would allow for the functionality of being able to make an interactive visualization. So these are four types of visualizations I'd like for you to keep in mind as we're going through the remainder of this presentation, and as you start thinking about the different types of visualizations that you want to create, either using your own data, or if you're developing curriculum, what type of visualizations you may want your students to explore and to work with. So I have a question. So what is the key element required for all data visualization projects? And so, Kate, if you can monitor the chat and see if anyone has any guesses. What's that key element that's required for all data visualization projects? No guesses?
People are saying data.
Exactly. Yes, that is the key element. Data. You can't do data visualization without data. And so data is everywhere. It's ubiquitous. You can't escape it. We are creating data. We're using data. We're seeing data all the time. And so when you start thinking about a data visualization project, if you don't have data, then there's basically nothing that you can do. So very, very good on that. So yes, that key element that we need, or you need for all data visualization projects is data. And so be thinking about, where does the data come from? What can you do? Where are your data sources? So that's not something we're going to get into this webinar, but I will start asking or posing some questions for you to start thinking about as you start working with your own data. So the purpose of visualization, in one word, is insight. It is in pictures. And so, as I alluded to earlier, most people think, with data visualization, you create a pretty picture and you're done. That is not the case. The pretty picture to me is the icing on the cake. It is, remember, it's the process, is where all of the exciting things happen, in my mind anyway. And so when you're doing data visualization, keep in mind that 80 to 90% of this process is about cleaning the data. And that within itself is a whole nother webinar that we could hold on cleaning data. And so this thing, like I said, it will not be a one and done thing, but you want to be able to take that data and turn it into insight. And so how might we do that? In this slide, I included it because I really like the way it lays out the steps or the stages that you go through in transforming raw, unfiltered data into a format that it needs to be in, not only to be able to get that data into a format that you can read it into a visualization tool or software, but also it walks you through these stages that get you to that very top. So you start out with data, all raw data that has not been manipulated or changed in any way, and you try to identify the relationships that exist in the data. And that process itself, or that step itself, changes the data into information, because now the data becomes information when it has some kind of meaning. And you want to try to understand the who, the what, the where, and the when in this process. Once you have that understanding, you try to identify what patterns exist in the data. And that is the main part of data visualization, or one of the main things that it allows you to do, is to identify subtle patterns that exist. If you have a very large data set that you cannot just look and just eyeball it just to see what type of patterns are in there, maybe you need some other resources that would help you to do that. So once you identify the patterns, that information has now become knowledge. And knowledge is information that is aggregated to a point where it has meaning and purpose. And as you can see in this slide, the how. Once you identify the how of that data that you're dealing with, now you're looking at, or you can explore causality, which brings us to understanding. And so hopefully you can see there is a natural progression going from raw, unfiltered, unstructured data up to looking at the analytics or the cognitive part of the data that you're working with. And so at this point, you are trying to synthesize new information from what is already known. And you start looking at, what are the principles that exist or that can be applied here that will allow us to gain more wisdom. And that you're at the top of this particular chart, and you can see, once you're there, once you have a better understanding of all of these stages that have occurred below, you are able to make some predictions. This whole thing is about decision making. So when you create a visualization, sometimes you're trying to convince someone of something. Remember those four visualization types. Maybe you're trying to prove a hypothesis. Once you have gone through this process of transforming that data into insight, you are well on your way to actually creating some visualizations. And so understanding the data behind the visualization is just as important, if not more, than creating the visual representation as well. So if you will, just kind of keep this in mind as we start talking about the data visualization process. We're always trying to go from data to insight. So another question. So when should you start thinking about visualizing your data? So at some point, we've all visualized some type of data, whether that was in school or in a class where you had to make a presentation. Maybe if you're a graduate student, creating a poster, writing a paper. So when do you think, or when should you start thinking about visualizing your data? And random guesses are appreciated. I can't see the can't see the chat. Do we have any?
Maddie says, as early as possible.
Absolutely,
Amy
yes.
says, before collecting it.
Yes, absolutely. You are absolutely right. And so normally what I would ask is, when do we actually start thinking about the data? Because sometimes we know we should start early, but that's oftentimes not the way in which it happens. So yes, you should think about it early and often. And so as you think about the different types of data that maybe you worked in the past or you're planning to work with, how big is the data set? Will you need high performance computing resources in order to, if not for the creation of the visualizations, just to manipulate it or to explore it, to get it into the format that it needs to be in? What does the data look like? You remember in the previous slide, data could take on the form of many different forms. And so you need to know what your data looks like, because that's going to inform what you need and the different type of tool that you need. Who's your target audience? And so that's also important in questions that you need to ask, because depending on who your audience is, that's going to dictate or determine the type of visualization that you will create specifically for that target audience. And what type of visualization tools will I need? So I can tell you up front, you will need a tool that will help you to get the data into the format that it needs to be in, to mine the data or to reformat it or to regroup it or whatever it needs to be done to the raw data. You will need a tool for that. And then depending on the type of data that you have, the data dictates the type of tool that you would use. So there is no universal tool for all types of data. And so you will have to make some assessments of your data. You'll have to think about who you're presenting it to, and you have to think about what is the best way, chart types and different types of things, like color and perception, all of those things that come into actually creating the visualizations that will provide you the insights that you're hoping for. So yes, think about your data visualization or how you're going to represent that data early and often. Again, this is not a one-time thing. Your first visualization will not be your last. And so that being said, you want to allow enough time for yourself to work through this process of reiterating or refining and updating. By the same token, the first visualization tool that you learn how to use and you're comfortable with will not be your last either. So you need to be in the mindset of always learning and being open to trying out new things. Okay, so now what I want to talk about is the data visualization process itself and or workflow. So what I want to impress upon you is that there are several different versions of a data visualization process or workflow. And again, it gets back to, what does the data look like? So if you're dealing with scientific data, you may see a workflow that looks like this. And remember, the data dictates the type of tool that you will use. And in this case, it's going to dictate the workflow that you're going to see, those different steps, stages that you will encounter. If you are dealing with ArcGIS or geographical data, then there is a different type of workflow, mainly different steps that you would go through in order to get that data from its raw format into maybe ArcGIS, or with this type of data, you would need longitude and latitude data. So be thinking about, again, there's no universal workflow, but I do want to say that this process is nonlinear and it is an iterative process, which means, as I've said before, your first visualization will not be your last. And so I want you to be thinking about, what does that mean? And so what we're going to do now is I'm going to walk you through this process. So this is another layout workflow for data visualization. And I like this workflow because it's very simplistic, particularly for those who are new to data visualization and understanding the process. And so although these stages look different, as you look into what actually happens in each of these stages, even though you'll see a different workflow, you will see elements of these basic stages in each of those different workflows. They may be labeled differently or called something different, but as you begin to understand each of these stages, you will be able to see, even though the workflow may look different, let's say for scientific data than for information visualization data or business data, those same stages or steps that are implemented in this are also present in those other workflows, maybe just called by a different name. So I want to point out the red arrows here is meant to indicate the iterative non-linear process that exists in the data visualization process, and then also taking note of Bloom's taxonomy that is utilized here. And we'll come back and revisit this as we get into the curriculum development portion, but I just wanted to point this out for a second. So if we're going to walk through this process, so the first stage, first of all, I want to say you can be in any of these stages at any given time. I am presenting them in a linear fashion in this webinar so that I can take some time to explain what happens in each of these stages. But keep in mind, you can be in any of these stages at any given time, which means you could be at the end and then maybe you make some revisions and you may have to go back to the first one. So view this as a introduction to the different stages, 7 stages in particular of the data visualization process. So the first stage, as we said, the key to any key element for any visualization project is data. And so where do you get the data from? How do you acquire the data? And that answer is going to be different depending upon what your research needs are and what your project is. In some cases, the data will be given to you, in which that would be considered possibly secondary data. For some of you who are going to do research, already have done research, you collected your own data, and that would be considered primary data. And so depending upon your sources, the data could be text, it could be images, it could be coordinates, it could be any number of things. And so for this example that I'm going to walk through, this is a very simple, basic example, just for the purpose of showing you what it might look like to go through this process. So as you can see on the right-hand side, for this particular example, the task is acquiring data. And so for this one, we have a few bullet points showing the data that's being collected. And I also want to point out at the bottom of each of these slides that I'm going to show, you will see some links to the different stages. And so what this is intended to do, one, is to show you what the next stage is after you are finished in the stage that we're currently in. For example, here, we're in the acquire stage. So the next stage would be to parse that data. You also see that there is a line or link to a future stage, which is the represent stage. So we will come back to that, but I just wanted to show you or to point out, as I'm going through the remaining 6 stages, you will see that these arrows will change to point to the next stage, but also to indicate that iterative nonlinear process that I mentioned before. So let's say we've acquired our data. In this case, we'll say it's very simple. Our next stage is the parse stage. So for parsing, this is where the data changes into a format that tags each part of the data for its intended use. And so this is where you will break the data down to see what does the data look like. This was one of the questions that I asked on the previous slide. And so you may be asking, why is this important? Well, in this day and age of AI and all of these things that are done for us, it is very important for you to know what the data looks like, just in case if something is misinterpreted. Let's say you're expecting the data in a particular column to be a number. And for some reason, when it's read in, it's a character or something like that. As simple as that sound, that could lead to hours, sometimes days of trying to debug and figure that out. And so in this case, parsing is very important. Now, for those of you who are programmers, this is in no way the level of parsing that you will do if you're a computer scientist. But the idea here is to give everyone some talking points and to be able to understand, to have an intelligent, informed conversation about parsing. And so at the very least, expect to know what a string is, what a float, a character, or integer. These are very basic. There are some other data types that are available out there that you should be aware of, but these are some things very basic that you're likely to see in some form or fashion. So take a look at the bottom of this slide here, and you can see we're now in the parse stage, which meant that the input to the parse stage was the output from the acquire stage. And the output from the parse stage is going to be input into the filter stage. So let's see what the next stage brings us to. As the name implies, this is where you will remove portions not relevant to your use at this time. And so I want to caution you and just take note that remove does not mean delete it. So you may, if you have a large data set that you're working with, I would say save a subset. After you filtered out the information that you're going to be working with that's relevant at the time, you always want to keep something, that original data set available, because you may need to go back to it. And so with filtering, you're extracting just those parts that you feel are useful for the moment, but also keeping the remainder of it just in case you have to go back and take a look at things. And so if you look at the bottom of the slide, you'll see we're in the filter stage. The next stage will be mining the data. And then from there, presenting, and then from the represent stage, that could lead to, again, that iterative nature that we mentioned before. Once we're in the mine stage, this is where things get really interesting, because this is where we start involving math and statistics and data mining, all these things that give us a better look into what that data looks like. And so still keeping in mind, we want to go from data to insight. And so mining that data will allow you to understand some specific things about the data that will help you to describe it to describe it to someone else who may be looking at the data at a later time. So in the mining stage, it helps you to figure out things like the minimum and maximum values for numerical data, figuring out frequencies of other values. And remember, we talked about looking at the patterns that exist in the data. And so it is in this stage that you will do that. We are just now getting to actually representing the data. Remember, visually, remember I said 80 to 90% of this process is about getting the data into the format that it needs to be in. And so it is in the represent stage that is considered to be the linchpin of this process, because it is this stage that could very well result in you having to revisit previous stages. And so we've all had, or I had several experiences where I've represented something or I've created visualization for it, and I thought, oh, this is great. Let me show it to a colleague and see what they think. And I find out that it is not being interpreted the way that I had hoped that it would be. And so that means, and sometimes I need to go back and maybe filter out. And filtering could be adding data, more data back to that subset. And so it just depends on where you are and what you're doing and what answers that you're trying to achieve. So our next step in this process is the refine stage. Once you get feedback, and you always want to be in communication with someone or getting feedback from someone who has a fresh eye to the work that you're doing, because sometimes we work so closely with data and with the visualizations that we create that sometimes we can't see those things that others can. And so in this stage, this is where we release our work to others and hope that they will be honest but supportive of the work that we have created. And so getting that feedback is very crucial. And so again, this is where that iterative process comes in, you may have to go back or decide to go back and revisit some of those previous stages to help more clearly define what you're trying to do. This last stage, which is not always implemented, but it is there, it is the interact stage. And so this is the stage where you completed all the previous stages, and now you want to allow your user the opportunity to engage more with the data. And so by making it interactive, that allows the drill down feature, it allows participants or viewers to explore the data a little bit more, to see what happens. And so there are a lot of tools out there that can help to facilitate that and enable interactive visualizations. So with our 7 stages, these are the basic stages. Like I said, you will see these in other visualization workflows, but they may be named differently or labeled differently. But what do we know from what we've just gone through? That is, output from one stage serves as input to the next. It is, as I mentioned, an iterative process, so give yourself enough time to actually go through this process. And your first visualization will not be your last visualization. And your first visualization tool that you will use will not be your last as well. So in the interest of time, I'm going to go on to data visualization for computational science. And so for this part, I just want to point out a few things. If you're thinking about data visualization and data science and computational science, there are some essential skills for data visualization that are recommended. So you don't have to be an expert in all these things, but having some knowledge and some working knowledge of these things would help a lot. So programming, very important. I've listed R and Python as the languages that are recommended because programming is going to be key for being able to do the interactive things that you might want to do with your data. These particular ones are very flexible in the sense that Python can be used and is used in a lot of different things that can help you to visually represent the data either online or in static form as well. Software expertise for computational visualizations, MATLAB is often used, Minitab and SPSS. For data science skills such as statistical analysis, data cleaning. We talked a little bit about that in the previous slides, processing large data sets. And so it's going to be important that I'm going to skip down to the last bullet. Machine learning algorithms and techniques can be very helpful with the large data sets. Presenting your work, that's one thing that we have to do, or I encourage you to be able to do. And so being able to present your work not only to your colleagues who know what you're doing, but also to others who may not be in the discipline, but visualizations would help you to communicate what you're trying to do to the novice person as well. So here's some resources for visualization for computational science, some visualization tools, Jupyter Notebook, Jupyter R, and I provided the links here. These slides will be made available to you after the webinar, so you'll be able to go and take a look at these resources. Tableau, they have evolved or built up into it visualization AI techniques for big data and machine learning apps. And so it is a very robust tool. There is something called Tableau for teaching. And so if you haven't used that, I do recommend that you take a look at that. If you go to the Tableau website, there's some information there. If you're thinking about integrating Tableau into your current curriculum or learning it for certifications, this is definitely, I think, a really good resource for that. D3, data-driven documents. We talked about interactive visualizations. And so this is a opportunity to showcase your programming skills a little bit, because it does require knowledge of HTML and some others as well as listed here. But this gives you a lot of flexibility and much more control over how your visualizations can be visually represented online. And here are some others. This list of resources will be in our resources document, but I'm just kind of showcasing or hiding them here. And then I've included IDL, interactive data language, This is software that's been around for some time, a very good software package for doing a lot of different types of visualizations, depending upon what your needs are. And so I do recommend that you take a look at that as a resource as well. Getting on to curriculum building. I have taught data visualization for some time here at Purdue, and in that process, I have come across some things that I feel are layers for building data visualization capacity. And so one thing I like you to think about is, what is your data visualization capacity? And so I linked the things, these layers to Bloom's taxonomy, so that if you're interested in building curriculum, you can create learning objectives that fall into that space. And so for understanding, the understanding level is just fundamental awareness about data visualization. You're a learner, according to this model here. Limited experience, basic knowledge. Once you do get that fundamental knowledge, I would consider you to be a user, an intermediate, at the intermediate level. Practical applications, you're learning Tableau, you're learning how to use scientific visualization applications, all these different things, and these other tools that I presented on the previous slide. Most people, this is where they want to be, and they're happy, and that's fine. You know, I want to know how to use the tool. I want to know which tool to use. I want to know which chart type to use, depending upon the data that I have. Some people want to go a little bit further, and so I consider that to be advanced. And this is where you're at the analysis stage of this, and this is where you're applying all of you have mastered all of these things below these levels at the application and understanding level. And now you're more into the data science area. And lastly, you get to a point where you are ready or want to create your own visualization tools and not just depend on the ones that are provided for you. And this is how most of the open source tools came into development. And that is, you have a tool that maybe does not have the functionality that you're looking for, all of the functionality that you're looking for. So what do? If you are comfortable programming, you write your own. And so there are some classes that I have created, and I'm going to share in a moment some tools that I've used in these classes. And so there's an introduction to data viz, and then building on that, there is a data viz 2, and then there's data visualization tools and applications. And so depending upon what the interest is, there are lots of resources for those. So now what I want to do is to talk about this data visualization capacity tool for teaching and learning data visualization. And so this tool is something that's still very much under development, but I would love your feedback to take a look at it and see. Hopefully this will be something that you can use in your classes. And if you see something that could be improved, feel free to share that with me. And so this is what I'm calling data viz a la carte. So I've just gone through all of those stages, and you may be thinking, I don't have time to put all of this into my curriculum. I know. Or you may be thinking, oh, this is just too much. And it could possibly be, because I know we all are strapped for time in our curriculums. But the purpose of this is to provide you with a tool for teaching and learning. And so if you're interested in figuring out, okay, how can I teach data visualization? This data viz a la carte will allow you to pick and choose those parts of those pieces that you think you have time for to fit into your current curriculum. You may be thinking about developing your own data visualization course. There is content in this as well. And so it has a modular structure that will allow you to go at your own pace. And it is well suited to the nonlinear iterative nature of the data visualization process that I mentioned before. So here we are. This is a screenshot of the workflow. And so you will get the URL for this in QRC code in just a moment. But I just want to take a moment to kind of highlight the different things that are in there. So you will see this workflow that I just went through. There are additional things for each of the stages of the data visualization process. So there's two parts, one about the overall process itself. So you may not be interested in diving really deep into each one of those stages. You just want the high level overview of it. This would be the place to start. And so in this module, there is workflow, there is objectives that are listed. Again, these align with Bloom's taxonomy. There's assessments that self-assessment that either you or your students can take to kind of see where you are and see where you need to focus more time and more attention to in the process. And there is a evaluation matrix, which kind of summarizes those things that are aligned with the Bloom's taxonomy for each of those stages. And so as you can see, you can go from lower order thinking tasks to higher order thinking tasks. And so that's a way for you to assess how students are doing. So I'm just going to go through this kind of quickly because I want to leave room for questions. But one thing I want to point out is that for each of these modules or sections of this, there is a review tab. And in that tab, it shows you, or it indicates what you should know and what you should be able to do. Because I think that is very important for students, but also for instructors who are teaching data visualization to know what the next steps are and what should be the outcomes of this. And so if you go to this QRC code right now, you can see this is a demo of this. And so it walks you through those stages that I just mentioned for the overall process. It walks you through those stages for the acquire stage of the data visualization process. And in this tool, there is a module for each one of these. And so that just kind of gives you, I'd like for you to just kind of navigate that on your own or just kind of look through it as I'm talking through what the possibilities are here. And you'll get the link to the full version of this as well. But I just wanted to take a moment to just kind of point out what the structure of the module would look like. Now, for those who are interested in teaching data visualization and maybe not knowing where to start, in this tool, there are learning units. There are 3-hour units. There's a 1-week unit, three-week. And so I'll be adding more to that as we go forward. And as the needs arise, if someone contacts me and say, you know what, I only have 30 minutes. What can I do? We'll try to come up with a plan that will give you the maximum benefit for the time that you have. So I just wanted to point that out. Keep in mind, this is a work in progress. And so things will be added as we go forward. So it's data viz, a la carte, data viz on demand is what I'm calling it, and hoping that it will be a useful tool. So here is the link to the full tool itself. And so you can either use this link or you can scan in the QRC code. All of this information, again, will be available to you on the project website that we're going to make available after the webinar here. So I'd like to take a moment to go to some resources. And so this list, I don't know what's going to happen here, but let's see if it will show. You also have access to this. Let's see what's happening. Can you see anything? Nothing? Yes, no?
It has, we just see the slide. It hasn't changed over to the link.
Okay, so I'm going to stop sharing and then I will share that document because it has really good resources in here. And what I tried to do, how about now? Can you see that? Okay. Yeah. So I will say there are a lot of resources in here. And so what I tried to do was to categorize them or group them according to those 4 different sections that I showed on the very first slide. And so for data visualization resources, what is data viz? Data visualization vocabulary. And so it talks about using, terminology for data viz and explaining what different things mean. Choosing the right chart type. That is probably one of the biggest challenges after you've gotten your data into the format that it needs to be in. What's the chart? What type do I need to utilize to show that there is I'm looking to show relationships within the data, or you want to show a distribution. And so this is a very good resource for that. There's a data visualization checklist. So there are data visualization best practices that you can use that to help you as you create your own visualizations. There's also some visualization tools and books This particular link, do check this out because it has, the last time I checked, over 400 visualization tools and books that you can explore. The nice thing about this link is that it also shows you, you can indicate if you're looking for books or if you're looking for tools, if you're looking for free tools, those types of things. So it's a nice filter, and it is being updated regularly. And so I think it will give you a nice resource to have. So I'm going to go down a little bit. Like I said, you will have this link and this information available to you. But I just want to point out some things here. Different types of visualization for computational resources. This is basically what was covered in the slide presentation, but you'll have this included as well. And then down here, data visualization for data science. Python, as I mentioned before, is a good language to learn or become familiar with, because as you can see, it is relevant in many other applications as well. There may be some applications that you're familiar with, some that you may not be, but I do encourage you to take a look at them. I tried to identify resources that were freely available or they have some type of training trial period. And in terms of the different types of visualization for computational representation of data, these are the most common types. These are not the only, but these are the most common types that you are likely to see. And then here for the curriculum building resources, here's the direct link to the tool that was just demonstrated there. This particular resource, very good for course material. It has slides, and there's also activities that you can work through. You can modify this material to fit your curriculum. And I think this is a very good place to start. Here's a list of visualization books. Edward Tufte, I just put books. If you Google him, all of his books are good resources. And so he's at the top of the list here. Visualizing Data. This is the book that was the source for that 7 stages of visualization that I worked through in this presentation. And so I think that book also uses a language called processing. Processing is a good programming language if you are just getting started with visualization. It's a good language to know and to learn. It's very easy. It's very intuitive. So you may find that to be helpful as well. And in terms of, lastly, in terms of computational things for curriculum building, here are some publications. Not all of them are by me, but there's some others that talk about teaching and learning, specifically for data visualization, ideas and assignments. And so these are the resources that I think would be helpful. Again, there are far more things that could be said, but in the interest of time, I pulled together what I thought would be the most beneficial to the most number of people. And so I'm going to just take one more look at the slides because I want to remind you, I need to share, sorry. Just realized I didn't. Okay. So I just want to remind you that we have some more seminars coming up as I scroll down to locate where I was. Okay, resources here. And so all of the information will be available at this link shortly after this presentation. And please save the dates for 3 other upcoming webinars. On April the 12th, there will be an introduction to modeling and simulation, May 10th, introduction to matrix methods for data science and machine learning, and on May 17th, Science Gateways as a classroom resource for computational and data analytic tools. And so with that, I thank you for your time today, and we'll open the floor for any questions that you might have.
Great, thank you, Vitria. And yeah, as Vitria said, our project website, we have our webinar series material there. And so I'll be posting the resources and the slides that Vitria shared, as well as the recording once that's available. And I'll send that out to everybody next week, probably. So you can be reminded to go and look at that and get those resources. But if you have any questions, feel free to unmute and we have some time for discussion.
Okay, someone has a question is for computer science. It kind of flashed up and went away. Let's
Do
see.
you recommend teaching computer science students tools such as Tableau, or is it better that they learn the coding and visualization in R or Python libraries?
That is a very good question. And so I would recommend that they learn the coding, and they do that first. I mean, they can always use Tableau for the simple fact is what happens if they don't have access to Tableau? And so being able to understand what goes on behind the scenes in a sense and being able to code that, I think that would make them more marketable. To say that, yes, I can actually code in addition to, yes, I know how to use Tableau. But that's just my personal opinion.
So there was a question earlier about sort of working with different data from different sources. So if you're doing a project where you're generating data from you're doing some testing or experiments. So in that case, you already have questions you're going to be asking, and you're going to analyze the data. But then in other projects where maybe you're not generating the data, you're taking it from some external source, or have an existing data set. How do you come at those different types of projects looking at the data?
So when you're working on a project where you're getting data from multiple sources, communication or figuring out what that data looks like is going to be very important because a number of things happen. Everybody collects data differently, and unless there is some unified, agreed upon way in which the data is collected, some time is going to be needed to create, for lack of a better word, some type of library or mapping so that you know what you're getting from those multiple sources. And so if you are getting multiple sources, let's say from collaborators or colleagues, then of course that communication with them is going to be important so that you know what to expect and what the data looks like going in. Always documenting, creating, and this is work up front. And a lot of people say, oh, this is too much work, but you need to document what that data looks like, what data types are there, what are the different fields that you have, and what are the data types for those fields. For example, if you're, like I said before, if you're expecting a number, and then when you look at the data, somehow you end up with a text field, knowing that's where the parsing comes in, and knowing what that data looks like will help you to figure out how to create a mapping or some type of understanding of what that data that you're merging will look like once it's merged together. So I would recommend backing up everything before you merge it, because sometimes, we're human, we do things. And so you may need to go back to that data. So always make a backup before you try to clean up the data or to put it in a format that it can be used in. Did that answer the question?
Mm-hmm.
Okay.
And there's another question from Maddie. In your experience, what do you think the biggest hurdles students encounter in making not just a visualization, but a good visualization?
That is a good question. I think one of the challenges is understanding what the best practices are, and understanding that you have to make some decisions as you are creating these visualizations. Color, perception, those those types of things are elements that sometimes students struggle with, and getting feedback, because oftentimes they will create a visualization and it makes really good sense to them and it looks really good on their display. And then when they share it with, on a big screen or whatever, and others start to critique. And that's one of the stages that we didn't see in those 7 stages that I've added when I teach data visualization is a critique stage. So getting some feedback and giving constructive feedback. And so although the feedback may not align with what they were expecting, but to be open to saying, okay, you know what, maybe I need to look at this a little differently. So I think learning just what type of chart type to use for their particular data, for whatever it is that they're trying to convey. That I found has been a challenge as well.
Mhm. And there's another question. Can you comment on the use of repositories for capturing resulting artifacts, documentation, code, test results?
So those are, I think, good sources. You have to identify, are they sources that are going to be there for a extended period of time? And so in identifying your sources, you want to make sure that it's from a reputable source, but also those sources that are going to be there.
Mhm.
When you have repositories, most of the time, there is a structure that is required because of, there was a time in which data was just dumped in, and then it's kind of like potluck. You figured out you got something that worked well, maybe it didn't next time, but there is a movement in understanding and the value of having structured data. And so if you're working with repositories or repositories, you may want to see what are the standards for, or the requirements for adding to that knowledge base, because then that's going to tell you how well the data is curated and how much work you're going to need to do in order to make sense out of it.
Mhm. Mhm. Oh, okay. Well, I think we're just about at the end of our webinar session. So thank you, Vitria. That was excellent overview and so many resources. So that was really great. And thank you, everybody, for attending. As Vitria said, our next webinar is in about a month on April 10th, and that'll be Introduction to Modeling and Simulation with Ana Gonzalez. Thank you, everybody. Have a good weekend.
Thank you so much, everyone.